Okay, so let's talk about the relationship between the reaction rates and the stoichiometry of the reaction. So let's look at this example. So in this example, hypothetical example, we have 2 moles of A reacting to form 1 mole of B, right? So what we're going to do is look at the relationship between the coefficients of A and B and the reaction rate expressions, right? So the first thing we can conclude based on this equation is that every time 2 moles of A reacts and disappear, then 1 mole of B will be formed. So therefore, we can express the rate of the reaction as being equal to minus half of the rate of change of A being equal to the rate of change of B occurring. So therefore, that reflects the fact that, okay, the rate of formation of B would be half of that of A, all right? And that comes directly from the stoichiometry of this reaction. So for any reaction of this type, again, another hypothetical example, we can write down relationships between the rates of A, B, C, and D in this reaction. So the rate of change of A, or the rate of the reaction, I should say, would be equal to minus 1 over A, lowercase a, which is a coefficient of A, uppercase A in this reaction, times the rate of change of A, equals to minus 1 over B times the rate of change of B, equals to 1 over C times the rate of change of C, equal to 1 over D times the rate of change of D. All right, so for any chemical equation, once you get it balanced, then you can write down the rate of the reaction with respect to each reactant and relate one to the other based on the stoichiometry of the reaction. So we can apply what we have learned to this question, which gives you a balanced equation. And basically what they're asking for you to do is write down the rate expression for this reaction, which is similar to what we just did for the hypothetical example that we looked at earlier. So the rate can be measured as being equal to minus the rate of change of CH4, which is methane, and that would be equal to minus 1 over 2, the rate of change of oxygen, and of course we have 1 over 2 here because of the 2 here. And then on the product side, that would be equal to the rate of change of carbon dioxide. And then for the water, because you have the 2 here, then that rate would be expressed as 1 over 2 times the rate of change of water. All right, so that's basically how these different rates relate to each other. All right, I think I'm going to stop here for this video because I want to do a couple of examples before we move on to our discussion of the rate law. All right, so until next time.